Hello Physics, Mr. Singer here, and we are looking at Chapter 15, Section 2, page 526, and this is talking about diffraction. We've talked about it before, we've done it with ripple tanks and so forth, and here's a great picture showing waves coming towards a barrier, and then once it gets to the barrier, those straight parts of the waves continue, and then it diffracts around the edge of the barrier, and you get this curving pattern. Well, if we have one slit, you get some patterns, and what if we get two or more slits? And this is what this section is about. There's, as we talked about in this last section, how the waves can constructively and destructively interfere, so you get bright spots and dark spots. We did some calculations with them. Well, this is a similar story, but instead of having just one or two slits, we're going to have up to many more. First of all, this diagram here shows diffraction becomes more evident as the width of the slit is narrowed, which is kind of goes against what you might think it would be. So this is the picture of a light on a screen when the slit is wide. As the slit gets narrower, the pattern spreads out to where the slits gets very narrow. You get a very wide pattern. You can even see this when you go take your fingers and on a sunny day, put your fingers and move your fingers like this, maybe 5-6 feet above the ground, 1.5 meters above the ground, and look at the shadow made by your fingers. You'll see it's not a nice, crisp, clear shadow. And you'll see some of this pattern going on, although it's much more dramatic when the slits get very, very small. You can even see here some pictures of this particular washer and the patterns that are made by it. Now, a lot of the vocabulary in here is similar as to Section 1, such as maximum and minimum and so forth. But today we're going to talk about another really interesting thing, and that's called a diffraction grating. So that if we got many, many slits, instead of just one or two, we get a whole bunch, in fact, thousands of slits in a very small space. What can we get? Here we are again at this demonstration where we have a laser, then we have a slit, in this case 2 slits, and then we have the image formed on the screen. And like it talks in the Khan Academy video, there's bright spots and dark spots, but they're not clear cut. And again, as I move this slit thing forwards and backwards, you get a spreading out or closing together of the spots. Now, what if we replace this thing with a diffraction grating? Here's a diffraction grating, and I'm going to put it in front of the laser. So here's the laser without anything in front of it, and now I'm going to put the diffraction grating in front of it. And you'll see that it makes some really clear, bright spots. And as I move closer to the screen, you can see that there's more and more dots as it gets closer and closer. And so we can find very distinct bright spots and then very clear dark spots with a diffraction grating. So for the diffraction grating, we get some of the same effects that we get when we just have one or two slits. In fact, the equation to do the calculations is the same, and it has to do with this distance between the slits, which is extremely small, and we do not have to have a lens. In fact, I'll do a little demo for you in a moment to show you how this can work, and you don't need a lens. But that distance is still the distance between the slits, although there are many. In chemistry, we do a lab with the light bulbs for different elements, and we shine it through a diffraction grating. This is the image of the light coming through the diffraction grating towards you. You're going to get a bright spot potentially near the middle, and then we get rainbow effects because we got multiple light waves coming through, and each color is bent slightly differently. And so if we would just have yellow light, why we would just get one here and one here. And again, you get a first order, second order, and so on. But for each color, it's a slightly different angle. So this is part of where we can figure out the wavelength from our equation. Shows the wavelength is related to the angle in which it bends. So the calculations for this are very similar to what we did in the last section. One little trick that shows up is when it tells you, when we need to find out what D is, for our equation we need to know the distance between the slits. Well, usually when a diffraction grating is made, they tell you how many lines per some length. It could be per millimeter, per centimeter, or whatever. Here they're saying it's 150,500 lines per meter. That's an amazing number of lines in 1 meter. Well, that doesn't tell us exactly how far it is between each line or each slit. So what you have to do is to find D, you have to take 1, which is 1 meter, divided by how many lines there are, and that'll tell you the size it is per meter. So they left it in a fraction. You could turn it into a decimal, and they use it here in the calculation. But that's the one little trick you have to do to figure out the D. Otherwise, the angle and things like that are still the same. So your homework is right here, numbers 1 through 5, and right there are the answers. Now, as someone put in my book, number 1 is quite possibly the longest question ever. Well, part of the reason why is they say, calculate the angular separation of 2 closely spaced yellow lines. Well, we have 2 different colors of yellow. So it's kind of like in this picture, maybe a green and a blue, 2 different colors. So they're saying 2 colors of yellow. Here there's just 1, but there's 2 colors that are really close to each other. And they want to know, calculate the angular separation. Well, to find angular separation, what they're really asking for is if we had let's say we have a diffraction grating here, and you have a screen here. So if the diffraction grating, the light goes through it, it will send a light here, and let's say that there's another one right here, and they're both yellow, but yellow 1 and yellow 2. What it's asking for is what is the angle here? What's the angle here? So how would you figure that out? Well, you would have to find the angle of this guy. Let's say that this is 5 degrees. And then you have to find the angle of this guy. And let's say that that's 7 degrees. What would be the angle of this one? Well, you would go 7 minus 5 and find 2 degrees. So with this problem, first you're going to have to find out what the angle is for one color and then for the other color, and then find the difference for the one color and then the other color and find the difference. And then they're annoying because they don't just say for the first bright one, they say for the next 2. So there's another one, yellow 1 and yellow 2. And so you have to do that again. You have to find the angle of the first one and find the angle of the second one and then find that difference there. And then for the third one, way out there, because it happens many times. And so you get to do 6 angle calculations and then subtract from each other. And so there's quite a few calculations for that number 1 problem. And again, there are the answers. Okay? So that's it for the homework. So for this lesson on diffraction and diffraction gratings, I wanted to show you that Khan Academy has a great video. I just typed into Google Khan Academy diffraction, and then the video shows up, and you'll see that down the side here, there's lots of different videos that are all in line with the chapter that we're learning about, including the thin film ones that help explain why a bubble or oil has multiple colors. But this diffraction grating one is a great video.
Double slits are cool because they show.
Okay, that was loud. So you can watch this video and it explains for you how the diffraction grading works and the calculations and understanding the concepts. Just a great video. I encourage you to please watch it.